I hope you can see what I'm doing. I just want to go through this summary scaffold so that you're all set for tomorrow. We'll start with box number 1. So calculate the standard deviation. So in box number 1, I'm also going to have this linked in the email and on the OneNote so you can see the filled in version as well. But if it's giving you a score and frequency table, so that means that the score on the test, I don't know, 15, it happened 11 times. So it would be a lot to put in the standard deviation 11 times. So we can just put in a frequency table. So to do that, the instructions are shift, mode, and then you press the down button, 3, 1. Now that turns the frequency on. So now we're going to get this column here. Now we can enter the data. So mode, 2, 1, and we can enter our scores in that X column. So we have 15 equals, 16 equals, 17 equals, 18 equals, and then you can go across to the frequency table, and the frequency for 15 was 11 equals 8 equals 5 equals 9 equals, and then you press AC, and that stores the data into the calculator. Now you can go shift 1, 4, and to get the standard deviation, that's number 3, and then we press equals, and that gives us our standard deviation. All set, that's box number 1. Now box number 2 says compare the 2 sets of data using mean and standard deviation, consistency, accuracy, etc. So that was our Mario Kart activity, and also our like texting boys versus girls. So this comment just says the smaller the standard deviation, the more consistent the data is because the scores are closer to the mean. So standard deviation is basically the distance, the average distance between each score and the mean. So if they're closer to the mean, if they're like tighter in, it must mean they're more consistent. So that is the only comment that you have to make. If it asks for comparing 2 sets, you just find the standard deviation of both sets, and then you compare which one is lower, and that's the more consistent one. Awesome. Also with standard deviation and comparing sets and things like that, this is what we were talking about in class. So this says if you add a constant k to a whole set of data, then the new mean is going to be the old mean plus the constant, and the new standard deviation is going to be the old standard deviation. So a question would look something like a set of scores with mean 22 and standard deviation 16 has 2 added to each score. And then the new mean is going to equal the old mean, which was 22, plus the 2 that they've added to every score. So the new mean is going to equal 24. And the standard deviation is going to equal the old standard deviation, which is just 16. And remember, I also said I did this image that if you have a set of data and you add to it, the range and the standard deviation stays the same because we're just shifting the numbers but not their position, kind of thing. Awesome. Now, if we want to calculate the mean, we can do like summing it all together, dividing it by the number of scores there are, or we can just put it into the calculator. So if we were here from our last standard deviation that we just found, if you were doing a new set, you can go mode to 1 like we did before, enter data, and then AC, or we can go shift 1, 4, 2 equals. So our mean for our previous set of data up here is going to be 16.36. So just having those calculator steps is all you're going to need. Then down here in box 5, we've got construct a scatterplot given a set of data. So if they give you some data X and Y, to construct a scatterplot, you just need 2 axes, your X and your Y axes. You need an even scale on both sides, And one thing to note, I've got little squiggly lines here. That wasn't a mistake. That's our like lightning bolt. So if you need to change the scale at the beginning, it jumps straight from 0 to 5 and then goes up by 1. You can put a lightning bolt in. And that's just to say, oh, the scale's a little bit different here. And the same thing here. This jumped from 0 to 8. And then it goes up by 1. So we've put another lightning bolt here. But that's okay. And then all you have to do is you say, okay, the first point, the x point is 5 and the y point is 13. So we go across to 5, we go up 13 and we put a point. And then same thing, 6 and 11, we go across to 6, up 11, 7 and 12, 8 and 8, 9 and 10. So we're just plotting the points onto our graph. And this line here is the line of best fit, and that just goes through our points. Then box 6, identifying correlation between two variables. So if we're looking at a scatter plot and all of the dots form a perfect line, that's a perfect positive relationship because it's going up. Then if it's still positive, but the dots are kind of off the line, then it's a strong positive. And if it's still positive, but the dots are kind of like far off the line, then it's a weak positive. And the same is true for negative. So these ones are just facing downwards, so they're negative. But if they're on the line, perfect, close to the line, strong, and kind of around the line, they're going to be weak. But just looking at those keywords, that's all you need to know. Sorry if you can hear the cat. It's his dinner time. Awesome. And then we have identifying independent versus dependent variables in box 7. So if you have a scatter plot or a line graph or things like that, the independent variable goes on the x-axis and the dependent variable goes on the y-axis. And a good thing to get into your head is saying this statement. So you take one variable, so say life expectancy, and then you say depends on income. So life expectancy depends on income. So the dependent variable is life expectancy and the independent variable is income. And I would think of a couple others. So maybe shoe size depends on height, or like something like that, thinking about the relationship between those two things. In box 8, estimate value of one variable given the value of the other variable and a line of best fit on a scatter plot. So if you're given a scatter plot and we've got our line of best fit up here, and the question might be, find the height of someone who weighs 65 kilograms. So based on our data, we go across to 65 and then we go up until we meet our line of best fit. And then as soon as we hit the line of best fit, we head across to the other axis and we can see that's about 139, pretty close to 140. And so that would be the answer, 139 centimeters. So we just start on whatever axis they give us, head to the line and then head across to the other axis. Here, use the equation of a line of best fit to find the value of one variable given the value of another. So if you're given the equation of our line of best fit, which cuts through our scatter plot, it might be y equals 3x plus 7, so that's the equation of the line. And then the question might ask, find y when x equals 12. So all you have to do is substitute 12 wherever you see an x. So it's going to be y equals 3 bracket 3 times 12 plus 7. So we saw an x here and we subbed in a 12. That's all we have to do. And then we just solve it. So 3 times 12 is 36 plus 7. And then y equals 43. And that's it. That's our y value when x equals 12. Now calculate the correlation coefficient. So this is another calculator trick. So if it's a correlation coefficient, it's going to have two sets of data. So first we're going to need to go mode 2, 2, and that's going to give us two columns. We have our frequency table, that doesn't really matter. And so if we enter some data, it doesn't really matter what data we enter in both columns. Equals. Awesome. Once we've entered whatever data they've given us, we press the AC button and then we go Shift 1, 5. And to get the R, we press 3. So I'll put that as a 3, sorry, there. And then we press equals. and that gives us our correlation coefficient. And if we look at this correlation coefficient, 0.24, that's pretty close to 0. So that's going to be a weak correlation, but still positive, but still weak. So I don't know if you can see this, but I'll also attach this document. So the correlation coefficient can only be a number between -1 and 1. So if it's a 1, it's perfect and positive. If it's a 0, there's no relation. If it's -1, it's perfect but negative. And then the kind of like range in between 0.5 and 1, that's going to be like a high positive, whereas 0 to 0.5 is going to be a weak positive. So that just means the smaller the correlation coefficient, like the closer it is to 0, the weaker the correlation, which just means that the two variables that we're looking at on a scatter plot or something like that, they're not really related. So if we look at this scatter plot up here, the correlation coefficient might be something like 0.5 because those dots look pretty related. You can kind of see a pattern heading up, whereas something like our one over here, this is a pretty weak correlation because the dots are pretty far apart from the line. So yeah, the closer it is to 1, the higher it is. Then this one's hard. Interpreting data from line graphs, basically just being able to read a line graph. So knowing that if it's heading up, then it's increasing. If it's heading down, it's decreasing. Just kind of that sort of skill. And finally, this is the one, the calculating equation of the line of best fit given 2 points. This is a really tricky one. So I'm going to do this for you here. It's still on the sheet, but I want to show you exactly how I'm doing it. Okay, we have x, y, 5, 13, 6, 11, 7, 12, 8, 9, 10. Okay, so we have our set of data. I'm going to pick 2 points from our set. And so the first point is 6, 11, and the second point was 7, 12. I'm going to label this first point x1, y1, and the second point x2, y2. And we're going to use the equation y minus y1 equals m x minus x1. So m is our gradient, y1 is one of our points, and x1 is the other point. So first we need to find m, and that's going to be y2 minus y1 over x2 minus x1. So that's our equation for gradient. So wherever we see y2, we're just going to pop in what we said our value was. So that's going to be 12 minus, and y1 is 11, and then x2 is 7, and x1 was 6, so 7 minus 6. And that's going to give me 1 over 1, which equals 1. So that means our gradient equals 1. So we can pop that into the equation. And now the last step, well, maybe a couple of steps to go, but we pop in our point. So where we see y1, we're going to put 11, and where we see x1, we're going to put 6. So I've just substituted this point into this equation here. So I have y minus 11 equals 1 times x minus 6. 1 times x minus 6 is just x minus 6. And now I'm going to move my 11 over, so I'm going to plus it to both sides. So y equals x minus 6 plus 11. So y equals x plus 5. And that's it. That's the equation of the line. So that's also on this sheet here that I'll attach for you. Sorry if it's a bit messy. If you have any questions at all, just email. I'll keep my email active on my computer. And if you need me, I'm there before school and also at lunchtime. Okay, see you tomorrow. Bye.